Welcome everybody, and thank you for watching this pre-application presentation. This is Todd Harrington, the Global PetroFix Product Manager for Regenesis, and I thank you for joining us to watch this roughly 20-minute presentation on pre-application technical guidance, improving your rejection success. My image is on the lower left. That's my contact information as well, and I've also included an image of Ryan Hardenberger, our PetroFix project geologist, and his contact information. So if you have any questions that come up that are not addressed in this presentation, please do reach out to us and we'd be happy to follow up with you. My goal for today's presentation is to give all parties involved, consultants and injection contractors, a really good feeling for the product and best practices, and so that you have a really good start to the project. The information that I'm providing is, picking some of our best information from hundreds of applications that Regenesis ourselves have overseen. And I noticed that when people go into the field, with PetroFix in particular, since it's relatively new, they didn't always have the equipment that they needed, the tool tips, or the practices to just ensure product distribution. So we're going to go through those today. And the topics I want to cover are a product overview, mixing and handling, recommended tooling, distribution testing, making field adjustments based on distribution testing, groundwater sampling, and optional well flushing. So just to get into it, everything that I am talking about today is available online in written form or in complementary videos. If you go to petrofix.com/resources or /apply, you'll find all of our written application instructions shown here on the left. And at the /apply link, you will see a complementary video on a PetroFix, applying PetroFix, which actually shows a real application and the equipment used there. And that's, I think, around 10 minutes long. So please be aware of those resources. Today's presentation is going to focus primarily on direct push focused injection. Jumping in, PetroFix is a activated carbon remedial fluid that's paired with electron acceptors. It ships in two parts. The first part is the remedial fluid itself. It's the activated, suspended activated carbon. It ships in either a 55-gallon poly drum or a 275-gallon tote. If it ships in a drum, it has 400 pounds of PetroFix remedial fluid. If it ships in a tote, it has 2,000 pounds of remedial fluid. In general, any orders above 6,000 pounds, you're going to see that Regenesis tries to fulfill those orders with totes, and then any additional drums that need to be made to round out that order. For instance, if you have a 6,400 pound order, you may end up with 3 totes and 1 drum. The second part that ship are buckets of electron acceptor. These are 20 pounds of powdered electron acceptor salts in the buckets. The standard usage rate that we use across the board is 1 bucket per 400 pounds of PetroFix. So that means that if you have, say, 18 drums of PetroFix, you're going to have 18 white buckets of electron acceptor powder. The ratio for a tote, since there's 2,000 pounds of liquid in a tote, is you're going to get 5 white buckets per tote. So let's get into mixing and handling. When the product comes out in the field, you're going to have 4 drums per pallet. Those drums will be shrink wrapped to the pallet. In case of a tote, it's actually shipping in its own wire frame or metal frame. The electron acceptor buckets are going to be shrink wrapped either on top of the drums or totes or placed on a separate or open available pallet space with them. In terms of handling, when you receive the material, you do need to make sure to store in environments between 40 and 95 degrees Fahrenheit. And in particular, it's important that you do not allow PetroFix to freeze. So once you're getting ready to mix the material, you just pop off the lid of the drum or open up the tote and insert a mixing device to homogenize the PetroFix within the drum or tote prior to transferring that material to a mixed tank. What do you use for that? We recommend any high amp slurry mixing power tool. It could be a double-handed slurry mixer. It could be something similar to a high amp power drill. Using a slurry mixing head or even a paddle and propeller works. Really the goal is get something long enough that you can reach near the bottom of the container and create a pretty good vortex of several inches to get things swirling around. So as you're getting ready, for the first push and starting to mix the product, let's talk about that. Bullet point 1 is homogenize the PetroFix. We've already gone through that. So bullet point 2 is you need to transfer the PetroFix from the drum or the tote into a mixed tank. In the image on the right, we see a gentleman using a 275-gallon tote for his dilution tank. This is an actual job. And what is common and what they used here is they used an air-operated double diaphragm pump connected to a stinger inserted into the drum of PetroFix, or you can insert it into the top opening of a tote. And then transfer the required amount of PetroFix that you need, say, into a bucket and pour it into the mixed tank itself. Once it's in there, into the mixed tank that you're using, it only requires a minimal agitation to keep it suspended. And then at that point, you're going to want to add the powdered electron acceptors, per the guidance output page that you have in the field, and put that in, and then it will mix after only a few minutes of mixing time. Want to point out that you do not want to add the electron acceptor powder directly into the blue poly drum or directly into the actual product tote that's shipped to the site. Here's the output page that you should have been provided by the consultant, or if you printed yourself online. Most of them look like this, or very similar to this. This has panels on it. For instance, the upper left panel shows the PetroFix amounts and the spacing that you're going to go around at the site and inject at, including intervals. The panel on the right is the total volumes, and it shows that once you push to the correct depths, how much material you're going to need in terms of per point and per vertical foot. And then importantly, for the driller and getting started at the beginning of the day, you're going to need to know how much PetroFix and how much electron acceptor am I going to put into the mixed tank. So that's this panel right here. The mixed tank volume is by default on petrofix.com, I think at 275. That can be changed. If you're using a 500-gallon mixed tank or smaller or even bigger, you can adjust that online. If you're the injection contractor who didn't do the design, you can reach out to Regenesis or the consultant to have this changed so that it outputs the right amount of PetroFix and water you need for the mixed tank. So you can go through these instructions here and get the mix that you need. It shows the gallons of PetroFix and the pounds of electron acceptor and the total number of batches you need to complete the entire job. In terms of personal protective equipment, the PetroFix is non-hazardous, so it's very easy to work with. The equipment that is usually used for PetroFix is the same that you would use to be around heavy equipment. So you're talking about safety glasses, hard hat, face shield, hearing protection, safety boots, chemical resistant gloves. We put in coveralls and Tyvek as optional because while being non-hazardous, PetroFix does stain your clothing, and a lot of that is just wearing that in the field. I see people wearing in the field because they don't want to get it all over themselves. And please do upgrade PPE as needed based on site-specific hazards and requirements. Let's get into an important section called injection tooling. The use of PetroFix, and early on when people were bidding it, there's a lot of familiarity and availability in the field of using high pressure tooling, pressure activated tool tips or drop tips, all of which still produce quite a bit of pressure at a very small interval. And we're trying to do something different with PetroFix, and I'll get more on that in the next slide, but we do recommend fixed open or retractable multi-port tooling as shown in this figure. The rod that's being held by the person in this photo on the left is a top-down 3-foot multi-port tool. The one on the right is a bottom-up or retractable multi-port tool. Both are effective, and I would just leave it to the experience and preference of the injection contractor, at the site on which tool they want to use. We do recommend a 2 to 4 foot vertical multi-port tool. We do recommend to not use a 1 foot multi-port tool or a 5 foot tool. A 1 foot tool is probably too discrete. It's going to take too many pulls to get through your entire vertical interval. And a 5-foot isn't discrete enough. It's injecting over too large of an area in the subsurface. We do recommend pressure and flow meter gauges and have those attached to each point as shown here. I do want to come back and say that if a multi-port tool is a bit new to you, there is a web link I show at the bottom at www.shop-esp.com that you can go to and see an example of multi-port pullback tooling. So once you're all set up, once you've inserted these tools to the depth and pulled back and are ready to go, as a rule of thumb, you're probably going to want to see between 20 and 80 psi in pressure and flow rates of 2 to 7 gallons per minute as a rule of thumb per single injection point. This is just a rule of thumb. So let's say you're at 8 or 9 GPM at 20 psi and you're not fracturing, you're not getting surfacing. You're good to go, but we just wanted to give you a reference for what we normally see on site. I want to emphasize why these multi-port tools are important, and I'm going to say something also that at the end of the day, what we're trying to do with PetroFix is we're trying to flood versus fracture the material into the formation. What we're trying to do is get very even distribution versus uneven distribution, which can happen with high pressure tooling. At the end of the day, you're welcome to use any tooling that you want, but what we're hoping for is that if you take a core and verify, which I'm going to show in a couple minutes, and you see complete distribution, then that technique's probably fine. If not, you're probably going to have to adjust what you're doing. In the case of a multi-port tool, the reason we like these is they can keep the pressures down and the volumes up in terms of volumetric flow rates, and they can help distribute PetroFix into the many multitude of sandy, convective channels that you're going to find in the subsurface. So this animation shows a multi-port tool coming in top down and injecting over, say, a 3-foot vertical zone, and it will find and force PetroFix to flood through those conductive zones. Those conductive zones are the highways through which contaminants are going. So you can do this with low pressure or no fracturing. You're really turning those flux zones into carbon filters, and let's see what that looks like a little bit. So with that tooling, what we're hoping to see is uniform distribution. The image on the right shows a successful application with a multi-port tip. And you can see that where we attempted to inject, which is the 2 cores on the right, we have a nice uniform flooding through the formation. As you get up a little bit higher, there is more of a clay zone that's not getting a lot of groundwater flow. You're not seeing the PetroFix go into that, and that is normal. So I want to make a couple points here that we do recommend that you don't just assume that the product's going and distributing on the ROs that you need, but that it actually is. And then we use the color of PetroFix black to visually observe this in the field. The designs that we provide on those output pages are very good designs. They're very safe most of the time. And a lot of times you can just move forward with those and you're going to be fine. However, each site differs a bit. It could have a slightly different porosity than what we estimated, which means it could take a little bit more water to get the ROIs that we need. So it's important to confirm product distribution in the field. So I do encourage people to view our designs and output forms as a dynamic template or a map versus something that's static. That means that you must and only inject at those volumes and dilutions, but you can expect to make some modifications to achieve distribution. At the end of the day, if you can get something that's flooding and looking completely black like the image on the right, you're doing a good job. So how do we do this? Well, we look for the PetroFix. The distribution testing methodology is covered in written detail and fairly lengthy detail in our PetroFix Direct Push application instructions located online at this link you can see above. You can find it there. Let's talk this through in brief. The first thing you want to do is you mix up your PetroFix on day 1, and we recommend distribution testing, on day 1 before you start anything. And then I would locate your beginning injection point near a non-critical part of the site, say it at a cross-grading edge or somewhere that's not near a critical well, and get set up. Before you get started, we do advise, if possible, to take a baseline soil core. across the injection zone to see what's there. It does so happens that sometimes soil is already black, and we want to make sure that we're not confusing PetroFix with, say, naturally weathered hydrocarbons. Also, it's helpful to corroborate the geology that that you are expecting to see, and where the permeable zones would be as reference, that when you're pushing, just to know that you're doing everything right. At that point, go ahead and inject PetroFix at 2 or 3 points per the spacing and per the dilutions recommended in our design. After that's completed, take another continuous soil core exactly between those 2 injection points. So looking at the cartoon on the right, the black circle is a well. We chose in this cartoon to inject near a well. The red 1 and the red 2 are 2 PetroFix injection points. Once we complete those, then we take the yellow PetroFix confirmation soil sample right between them. You also want to keep an eye out on the monitoring well and seeing if its water starts to turn black, because PetroFix is flooding to that well location and through that well. So here's some images of positive indicators. Let's start with the images on the right. On the upper right is sand, and that's was brown. This is before the PetroFix application. And after that was done, we saw just a beautiful even coating as we uniformly flooded the material through the formation. If you see anything like this, you know that you're doing a good job. The other thing would be, say, if you take a baler, or if you have a low flow sampling pump on site and you start taking some groundwater, can you see the PetroFix hitting that well? That's a good indicator as well. You could also put, say, an ORP probe down in the well, and you can look for changes. Because you're using a different water source and mixing PetroFix, that injection water tends to be more positive in terms of ORP. You can also see that wavefront start to hit those wells based on changes in water chemistry. As of November 2020, all shipments of PetroFix include what's called a PetroFix Field Concentration Sampling Kit. Part of that kit is shown in the middle image in that 40 millivoa. You will have the capability to measure the concentration of PetroFix in the field as compared to a turbidometric visual colorimetric standard, or I should say not turbidometric, but colorimetric standard of 50 milligrams per liter PetroFix that we've provided. I'll get into that here in a couple more minutes. So what if you do all this and you take your verification core, your distribution verification core, and you don't see anything? That would be like the example on the lower right, where everything's brown and we don't really see any PetroFix, even little Ziva stripes anywhere in that core. What do we do? Well, the first thing I do is just double check that everything was done correctly and filled. Sometimes we make mistakes. Sometimes we inject over the wrong intervals, et cetera. But, and we also want to make sure that we're looking for PetroFix in the right zone. So if you take cores and you've got several feet of clay and you're looking for it just all over that clay, PetroFix isn't going to flood, into that clay. It's going to flood into the sandy clay, sandy silt zones that might be, in zones within that clay or around that clay. So make sure you're looking at the right zone. Double check spacing, double check volumes, double check your injection intervals. Important is to make sure you are injecting with pressure. Gravity feed is, in our opinion, is generally ineffective. You do need a pressure to force and get the volumetric flow rates that you need and the velocities to get product out into the formation. Do check tooling for clogged ports, and possibly try another soil sample, maybe a foot closer to an injection point. If you do all this and you still don't see PetroFix, this is the micro adjustments that I recommended earlier. I would recommend increasing dilution water by, say, 15 to 20%. I would consider injecting pressures to get it up. So if you're injecting and you're maybe at 5 or 10 PSI, but you're still at, say, 4 or 5 GPM, try getting up to 20 PSI if you can. Maybe get up a little higher GPM. A lot of times that helps. You can decrease injection point spacing by, say, perhaps 1/2 to 1 full foot. And you could call Regenesis for additional troubleshooting tips, and we would be happy to go through that. So kind of wrapping up here towards the end, let's say you've gotten distribution, you've done your distribution test, you're wrapping up. you can do an optional post-injection monitoring well flush. So those wells that got PetroFix in it, sometimes a client or a regulator may be concerned with PetroFix remaining in that well when you leave the site. You can do an optional water flush because PetroFix doesn't preferentially go into a well. It can be easily flushed out of a well. We do have resources online under our resources page. We have a well flushing tech bulletin and we have a well flushing calculator to help you estimate starting volumes to flush into that well to get it out. More for the consultants who are watching this, I think it's helpful to throw this in there now, but when is a good time to sample groundwater? That is always a question. So PetroFix usually clarifies in the formation once injected in a period of weeks to months to a clear or light gray. Sometimes on really highly contaminated sites where you're putting a lot in, it will go longer than 3 months. But either way, if you've got PetroFix in wells and you're taking groundwater samples, do avoid sending samples above roughly 100 milligrams per liter of PetroFix to the lab. As a rule of thumb, if you can see through a 40 mil VOA with PetroFix in it collected from a well, it's probably safe to send to the lab. It's hard to see through roughly 100 milligrams per liter. And as I mentioned earlier, all shipments of PetroFix now have a field concentration kit strapped to the shipment that you can use to measure what you have. There are other there is a PetroFix groundwater sampling tech bulletin online that I highly advise that you take a look at that has some other tips on collecting groundwater samples post-application. And wrapping up, the website does have all of our available resources at petrofix.com. This would include an SDS if you're looking for that. It would include case studies, including, as I mentioned earlier, other video tutorials and very helpful tech bulletins and app instructions. If you have any questions, like I said at the beginning, please reach out to me or Ryan Hardenberger. We would love to talk with you more. If you liked what we said today, if it was helpful and you did not have the whole team involved, feel free to forward this around, or really feel free to reach out to Ryan and myself, and we can also schedule a live pre-application call with, say, between the consultant and injection contractor and get the whole team on there. We find that that can be really helpful. We'd be happy to set that up. Thanks for listening to this presentation. I hope this makes the project a great success, and please contact us if you need anything. Thank you very much.